Okay, let's look at question 8. Okay, so there are 3 electrochemical cells set up as shown, the EMF or voltage of shown on each voltmeter. Okay, what you must remember is this, okay, because this question is asking for the reducing agent, right, the order reactivity of the metals. So the metals are usually on this side, okay, metals are. So metals tend to be able to be oxidized, isn't it? If it's very reactive, means it can be very easily oxidized. So the more negative E value, right? If this E value is very negative, it means that the metal can be more easily oxidized, right? More easily oxidized. It is a stronger reducing agent. Okay, so we're going to look out for things like that. All right. So remember, the more negative the value, the metal is a stronger reducing agent because it's more easily oxidized. So I already drew a real number line here, and this real number line represents the electropotential. So the ones on the right hand side are the weaker reducing agents. The one on the left hand side are the stronger reducing agents because it's more negative, isn't it? Okay, so let's look at the table. Okay, for copper, the electrode, the plus is actually for galvanic cell. This is the cathode, and the minus is the anode. All right. So copper and metal X, right? So since copper is the cathode, it will have a larger electropotential. Okay, larger electropotential. The copper 2 plus, right? This is the one with the larger electropotential compared to metal X and X2 plus. Can? All right. So I'm going to say this for copper is somewhere here because I remember it's something like 0.34, right? 0.34 for the electropotential for the copper. So where is X? Okay, X is probably the anode, right? The anode always have the smaller electropotential because it has a smaller electropotential. So this is where X is. I'm just gonna write down X. Okay, so this is copper and the side is X. Okay, so the next one, this is the cathode and this is the anode. But now the difference is actually 1.1. Okay, just now 0.5. So this is the difference here is 0.5. Okay. All right. So now the difference is actually 1.1, which means I believe metal Y should be somewhere here. Okay, because this gap now up to here is actually 1.1 volt. Can you see that? Okay, so metal Z and copper. So metal Z now is your cathode and copper is your anode. So which means metal Z would have a greater electropotential. So I'm going to draw Z over here. Right? So now they're asking you to rank from the weakest to the strongest reducing agent. You can see that the weakest is Z, followed by copper, followed by X, followed by Y. So that makes C the answer. All right, that makes C the answer. All right.